now. So what this is this is internalizing from age 11 to age 16. So child internalizing, again, we used this example previously, but now I'm simply adding a predictor, and that is depression, or dad's depression. That's what the D there means. I have the C underscore initially, meaning this is a centered variable, and it's standardized. So 0 is the mean. So I took the regular variable. It's like on a 1 to 7 scale. I'm just standardizing this. And so the mean has now become 0 and the standard deviation 1. That helps us to identify our high and low levels of depression really easily. I want to just run this without the predictor first. So this is a little bit different from the example right now, in that I have the use variables and I've left out the C depress here because I'm only going to do my intercept, linear slope, and my quadratic slope here, and then I've got the growth over time. And I'm going to have my plots here as well. So go ahead and save it, run it, and we'll take a look at the growth parameters here. I should note this is only with female children. So our model fit, that's pretty good, 0.062. CFI looks really good. We go down to the means, and we find that the intercept is significantly different from 0, but the linear and the quadratic are not significantly different from 0. Okay, so those aren't significantly different from 0. Our variances here of the intercept and the linear slope, they are significant though. So we can predict variance in those. Oh, that kind of got off a little bit. Now our quadratic slope here, it's just barely not significant, if you will. It's less than 0.10, but not less than 0.05. The models, and we didn't have this in here, but the model fit substantially improves when we add that quadratic in there. It's less than 0.10, so we're going to go ahead and we're going to keep it in there as we do our predictions. So I'm going to go back here and I'm going to add my C depress to my used variables, and then I'm going to take off this. So now I have dad's depression predicting the intercept, the linear, and the quadratic. And then I also have my plots here so we can look and see what our plots look like. So I'm going to run that. And I go down and I look at my predictors. Okay, so dad's depression does predict the intercept, all right? And it's positive. So the more depressed the father is, the higher the intercept of internalizing, right? That's not too surprising. There's no significant effect on the linear slope, though maybe less than 0.10, but we do actually have a significant effect on the quadratic. So depression does affect the quadratic. There apparently was at least enough variance in that quadratic to predict. So depression does predict the quadratic slope. Now, well, what does that mean? How can we see this? How do we visualize what's going on here? And that's where we're going to go to our plots for. So we're going to go up here to view plots, and let's first just do the estimated means. So if I do the estimated means, that's what it looks like. That's the average trajectory for child internalizing. Again, this is for females. So the quadratic was positive, so it starts out a little bit slower in the growth, but then it starts to take off a little bit more, grow at a little bit more rapid pace at ages 13, 14, 15. But what we want here, we want to know, well, what happens if we know that father depression predicts the quadratic and the intercept? So what would this look like for dads who are highly depressed? What would this look like for dads who are low on depression? Well, we can do that by going to the plots here again, and we're going to go to adjusted estimated means. So we're going to adjust the means based on our predictors. In this case, we only have a single predictor, and that is father depression. So double click on that. And now it's going to tell me to name a covariate set. Now when it's saying covariate here, what it's meaning is predictor of the slopes. Predictor of the intercept, linear slope, and the quadratic slope. Well, we only have one here, and that's depression. But you'd also be able to get others here if you had mother's depression or race or income or whatever else you put there. But we have to name it first. So I'm just going to give this, I'm going to name one high depression, high dad, depress. Okay, so I named that covariate set. And what you see here is you see that down here, it gives me a variable. It would list all of the covariates or all the predictors that I have in the model. I only have one, so there's just one here. So I'm going to double click on that. And the default is to use its mean. Okay, if you had all of your covariates at the mean, you simply get really what you would get if you had the your unconditional model. Basically, that's what you're getting. It wouldn't be exactly like your unconditional model, but it's basically giving it at the mean of all of your predictors. So this is high depression, and so we're going to use the number 1. Now, because it's standardized, that means it's 1 standard deviation above the mean. So high depression, a value of 1. Again, I'm giving depression, I'm giving this variable a value, and I'm giving it 1. So 1 standard deviation above the mean. We're gonna make that, call that high depression. All right, okay, so I just did that. Now I'm gonna name another covariate set. I'm gonna do low dad depression. All right, I'm gonna click on this, name it, and now it's gonna give me this again. I'm gonna look at it and I'm gonna use, so what would be a low value for depression, low depression? -1, so we're gonna use -1 on this one. So -1 is my low depression. Say okay. And now I'm going to name another covariate set, which is average dad depress. I'm going to name that covariate set. And I'm going to go here, and I'm going to use 0. I could just use the mean, because the mean is 0. But just to demonstrate, put that in there. So put it 0. So we have that. All right, now we have 3 covariate sets. And you can look here, it created this drop-down menu. If I wanted to go back to high dad depress, I could do that and display that. Oh, I'm using a 1 there. I could click on low depress. Oh, that's a -1. And then I can click on average depress. That's a 0. And you could just define all of them out. You could do very high depress, where it'd be 1.5 or 2 or whatever you wanted it to be. So you put in those values, and you just simply have to know, what are my high and low values? If I hadn't standardized it, I would probably look in the data and I'd look for, well, what's my standard deviation? Okay, the average is a 2. My standard deviation is 0.4. All right, so if my average is 2, then my high value would be 2.4. My low value would be 1.6. Right, just doing 0.4 on either end of that. All right, and then you simply say, okay, and you notice I have 3 different growth curves here. Now, M+ is a little tricky in reading these things because these look awfully similar to me, don't they? But let's start with the triangle, because we can tell what that one is. So low dad depress, okay? So when the dad has a low level of depression, you notice here the intercept. Well, let's just look at the average, I guess, first. This is our average. This is what we saw before. That's simply the average level. Okay, so then low dad depress with a triangle, well, it significantly predicted the intercept, so we'd expect the starting place to be lower. In fact, there it is. So it's lower than it was. And the curve, right, the average curves up, but now the average is actually curving the other way. Because at low dad depression, if you calculated it out, the value of the quadratic would be slightly negative. And so rather than picking up steam over time, actually the internalizing starts up and then it kind of starts to level off, right? So a very different developmental trajectory for internalizing if the dad's depression is low. Now here for our dad depression high, what we've done is we've just accentuated that curve. So we start higher because, again, the dad's depression affected the intercept. But then you see it kind of goes slow and then it really picks up. Right? It really starts to pick up a lot through. This is 11, 12, 13 is kind of the inflection point here. And after 13, we're really increasing substantially in internalizing behaviors till age 16. Right? So if you want to look at what is happening with your growth curve with predictors, this is the way to do it. It's going to calculate out all those values for you. It's going to display them. And then if you want the prettier graphs, you can click on this, and I'm just going to save this as quad growth. You could obviously name that anything. I'm going to go back to my M+ files, and I think I saved it in here, quad growth.dat. And those are the values. Right here are the values that it was using. So if I open up Excel, open up a blank workbook, put those values in there, and then I go to Insert, and I'm going to go to this one right here. This is a scatter, connected scatter, right? Again, I'm recording this so you can catch this. Scatter with smooth lines and markers, and then I select the data. I'm just going to highlight all this, and voila, there it is. And now you have it all in Excel, and you can, do whatever kind of things you want there to make it look prettier. Right? So very, very easy way to identify what these are called are prototypical plots. We refer to these as prototypical plots, or plots that represent the prototypical individual at various levels of your covariates. Now, let's say you had more than one covariate there. Let's say you had mom depression and, let's say you had mom depression and dad depression. Well, with the adjusted means, you could say, well, what if mom and dad are both high? So you set those numbers for high. So you'd have high mom, high dad. Well, what about if mom's really high but dad is low? What does that look like? And so you can specify all kinds of different permutations of all of your covariates there. Any questions on that? Okay. What happened to my Zoom? Oh, there it is. I need to stop